Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We started discussing the solutions of the problems that appeared in the CSIR National Eligibility Test held on February 28, 2025. Today, we discuss the solution of a problem from the section Complex Analysis, and this question is placed in Part B, which is a multiple choice question which carries 3 marks. The question ID is 704115. This question is suitable for all these examinations. Right. This question is related to Cauchy's theorem and Cauchy's integral formula. The applications of these two theorems are involved in this problem. The given question is for integers m, n greater than or equal to 1, means both m and n are positive integers, that means they belong to natural numbers. Let I suffix m comma n is equal to 1 by 2 pi I integral taken round c z power m into z bar to the power n, not z to the power of minus n, it is z bar to the power n integrated with respect to z, where c is the circle. The circle is the set of all z belongs to c such that mod z is equal to 1, which is oriented counterclockwise, that is, it is oriented positively. It's a positively oriented circle. Which of the following statements is true? We are given 4 options. These are the 4 options. We will discuss them in detail in the proof. Let's now discuss the solution of the problem in detail. We are given m and n are positive integers, that means they belong to the set of natural numbers, and I suffix m comma n is equal to 1 by 2 pi I integral taken round c z power m into z bar to the power n dz, where c is the positively oriented circle, that is, set of all z belongs to c such that mod z is equal to 1. On c, mod z is equal to 1, it implies mod z square is equal to 1. Mod z square is z bar is equal to 1. Therefore, z bar is equal to 1 by z on c. The integration is on c. That means z revolves round c. Therefore, z bar will be 1 by z on c while you are integrating around the circle c. Right. Now, I suffix m comma n is equal to 1 by 2 pi I integral taken round c z power m into z bar to the power n dz. For z bar, you write 1 by z whole to the power n, and that will be 1 by 2 pi I integral taken round c z power m by z power n dz. So, that is what we have, and we discuss the options one after the other in the next slide. We have I suffix m comma n is equal to 1 by 2 pi I integral taken round c z power m by z power n with respect to z, where m and n are natural numbers and c is a positively oriented circle. Right. Option 1. I suffix m comma n is equal to 1 if m is equal to n. What happens if m is equal to n? We will see. M is equal to n will imply I m comma n is equal to 1 by 2 pi I integral taken round c z power n by z power n. Why? M is equal to n. And this is 1 by 2 pi I integral taken round c 1 dz. What is 1? It's a constant, and every constant function is analytic everywhere. Therefore, it's analytic inside and on c. Therefore, by Cauchy's theorem, the integral will be 0. We recall Cauchy's theorem for your reference. If f of z is analytic in a simply connected domain D, and C is a simple closed contour lying entirely in D, then the integral taken round C of z dz is equal to 0. So apply Cauchy's theorem, we'll get the answer 0, but it is given 1. Therefore, option 1 is not true. We move to option 2. I suffix m comma n is equal to 1 if m plus 1 is equal to n. So you take I m comma n, and for m plus n, for n you substitute m plus 1. So this will be 1 by 2 pi I integral taken round c z power m by z power n. N is m plus 1. And after cancellation, it will be 1 by 2 pi integral taken round c, that is 1 by 2 pi, 1 by z. 1 by 2 pi integral taken round c, 1 by z dz. Right. Now 1 by z is analytic everywhere except at the origin, where origin is the center of this circle. So the 1 by z is analytic inside and on C except at a point z is equal to 0 which lies inside C. Then by Cauchy's integral formula, 1 by 2 pi integral taken round C 1 by z dz will be f of 0. What is f of z here? F of z is 1. F of 0 is 1. So the answer is 1. So we recall the Cauchy's integral formula. So applying this one, we will get the answer as 1. And the answer is given to be 1. Therefore, the option 2 is true. And it is from the section B, only one answer is true. Only one of the options is true. Therefore, option 2 is true. Our answer to this question is option 2. Anyway, we will talk about options 3 and 4 in the next slide. Right. Option 3. I m comma n is equal to 1 if m is equal to n plus 1. So wherever there is m, you substitute n plus 1. And it will be 1 by 2 pi integral taken round c z power m is z power n plus 1 by z power n. Then after cancellation, 1 by 2 pi integral taken round c z dz. F of z is z. Z is an entire function, analytic everywhere because it's a polynomial of degree 1. Therefore, it is analytic inside and on c. By applying Cauchy's theorem, the integral value is 0. Option 3 is not true because I of I suffix m comma n is given to be 1 when m is equal to n plus 1. But we got the answer 0. Therefore, option 3 is not true. Option 4. I suffix m comma n is equal to 1 if m is equal to n plus 2. You are observing the m means the power of the numerator. The power of z in the numerator is increasing. When it is increasing, you will get a power of z remaining in the integral after cancellation. Obviously, it becomes is equal to 0 by Cauchy's theorem. So you substitute for n plus 2. So it will be 1 by 2 pi integral taken round c z power m, for m n plus 2 by z power n dz, and after cancellation 1 by 2 pi integral taken round c z square dz. F of z is equal to z square is a polynomial of degree 2. Every polynomial is analytic everywhere. Therefore, it's analytic inside and on C. By Cauchy's theorem, the integral value is 0. Integral around C is 0. Option 4 is not true. Summarizing all the options, the answer to this question is option 2. That is the detailed discussion of the solution of the problem, which is based on the application of Cauchy's theorem and Cauchy's integral formula, which is a very simple and straightforward question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure that I am going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.